Hi, my name is Navita.
And I'm Simona.
And today we'll be discussing the fundamental laws of physics.
Of course, none of this would be possible without Isaac Newton.
So naturally, the laws that we'll be discussing are Newton's 3 laws of motion.
To start off, Newton's first law. An object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force.
In other words, an object maintains its state of motion unless an external force acts upon it. This law is also commonly called the law of inertia, which is fitting seeing as inertia is a reluctance to change current state.
Because in space, gravity is non-existent, this means that any object that was given a velocity in space will stay in motion forever until the object encounters a force on its trajectory. The implications of this are large for the space programs here on Earth because this allows conservation of fuel for rockets in space due to the absence of forces slowing down any vehicle with a velocity. This is just one example of how Newton's first law helps increase man's understanding of the natural world.
To help increase your understanding of Newton's first law, here's a physical representation of an object at rest encountering a force that causes it to have a change in motion. Here, a box is initially at rest. However, since Earth exerts the force of gravity on all objects in its atmosphere, all objects accelerate towards the ground, including the box. Without the force of gravity being exerted on the box will simply stay at rest after the hand releases it.
After establishing the fact that forces act upon objects to cause a change in state of motion, Newton thought about how to calculate the magnitude of the force exerted on an object. After experimentations and theories, Newton created his second law, which states, the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object.
In other words, to find the magnitude of a force acting upon an object, one can use the formula sum of all forces equals ma. The sum of all external forces, such as gravity and friction, is directly proportional to the mass of the object multiplied by the acceleration of the object. This formula is also possibly the most powerful and useful formula in the entire world of physics.
Say there's a box that weighs 15 kilograms that needs to be pushed by a person who exerts a force of 10 newtons. So, on this 15 kilogram box, there is a force of gravity, since it's on Earth, normal force, since it's in contact with another object, the ground, and the force of a person, which is 10 newtons. Using Newton's second law, or F equals ma, we can use this formula to calculate the acceleration of the box with the force of 10 newtons applied to it. In the x directional, we'll have the force of the person. In the y directional, or the perpendicular directional, we'll have the force of gravity, which is a negative force, plus normal force. Because this box is on the ground and with no incline, the sum of all forces in the y directional is 0, because normal and gravity cancel out. Therefore, the acceleration in the y directional is also 0. However, in the x directional, there's the force of the person exerting on the box, which is 10 newtons. An important thing to note is that in the x directional, there's only the force of the person due to the ground being frictionless. Therefore, we can use this 10 newtons to find the acceleration of the box, because we know the mass. We can substitute the mass of the box into the equation and make 10 newtons equal to 15 kilograms times the acceleration. You can divide by 15, and the acceleration will end up being 0.66 meters per second squared.
Now that Newton has established what happens to an object when it receives an external force, he begins to wonder what would happen to the object that had caused the force. This is how he created the third law. For every action, there's an equal and opposite reaction.
Also known as the equal and opposite law, Newton discovered that objects always receive the same force of exertion, regardless of mass. For example, if two boxes collide and the larger box exerts a force of 30 newtons onto the smaller box, the larger box also feels a force of 30 newtons.
Now you might wonder, how is it possible for two boxes to experience the same force without experiencing the same acceleration or change in the motion? This can be answered using Newton's second law, sum of all forces equals ma. Therefore, as the mass increases, acceleration decreases to compensate. While the two parts of the system are both experiencing the same force, one has a greater change in motion due to the mass of the object itself.
In conclusion, Newton's 3 laws of motion are what allowed for the development of new scientific discoveries in the world of physics and are the basics you will need to know to understand how the natural world functions.
Next, you can use the facts you've learned about Newton's laws in order to understand linear motion, where the application of these ideas can allow one to find important information of an object's path of motion in a two-dimensional world.
Thanks for watching. Like and subscribe, comment down below. Why do we even need to tell them the hard part? I didn't know that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force. And I was fine.